Okay. Hopefully this works. Oh, well. Okay. Okay, we'll just write this in. Accelerating charge in a vacuum. A little quicker than I did before, but if we have something like a cathode ray tube, which is a glass tube. There's a glass tube with a vacuum inside, or close to a vacuum. Okay, and we put electrodes on it, and we put a little shield here with a little slit, and we put a phosphorescent screen. We'll go negative on this side, so it'll be a little bit nicer. And if we apply a large enough voltage, we will find that what we can make is a nice beam of green light, which is the glowing phosphors. And what's happening is they're being excited by high energy electrons being accelerated across the voltage from one side to the other through the very tiny little resistance that you would find in the vacuum. Yes, question? Yeah, so the question is where does the green color come from, is what you're basically asking, right? So yeah, you can imagine these high energy electrons are bombarding the phosphorescent coating, which is likely phosphorus, and it's absorbing electrons, and then it's, it's knocking the electrons in the shells of the phosphor up to higher levels, and as they fall, right, they're emitting in the green range, right? You can't actually see the electron beam directly with your eye. It can't detect it's not built to sense an electron, but it can see the color here, right? So then we can, manipulate this with things like magnets, okay? So let's talk about the electron volt. This, by the way, is the basis of things like linear accelerators and so on, and your old cathode ray tube TV as well. If you were to look at it from this end and have the phosphorescent coating over here, you could get glowing stuff happening on this end, which with good engineering, you can turn into a TV. So the electron volt. Ooh, I don't like that color. Let's go back to this one. It's different than before. I hope you're okay with that. And I'm struggling. Oh dear. We'll get there. Okay, it's a different color too. Okay, so the electron volt. So the electron volt is a unit of energy. I'm not sure why it's doing this. Oh, I can use the back to erase. It wasn't working before. But it doesn't erase this for some strange reason. No, I refuse to start over. I'm getting upset. I don't know how to proceed here. Oh, okay. Is it back? I think it might be back. I hope it is. All right. I hope that doesn't happen again. Okay, so the electron volt. So basically, let's imagine that we have a parallel plate system, kind of like what we were talking about. We have, we can put it in a vacuum if you want to help picture what it would be like. Okay. We'll make it into a circuit. And we'll say that we have a 1 volt potential basically across this gap. All right? You can even put a switch on there if you want. All right? Okay. So when we close the switch, what would we expect to see happening here? What do you think would happen if this is a vacuum? seems to fix it. Okay, yeah, so you'd expect electrons to be zipping across here, okay? So the unit of, right, so now if we look, right, each coulomb of electrons has a charge of, like really, has a, has a potential of 1 joule. Okay, so each coulomb does. What an electron volt is it's saying, well, how much energy then does a single electron have in a 1 volt potential? If a coulomb has 1 joule total, then what would 1 electron have? 1, right, 1 coulomb, if you want, of potential. So how we would calculate that is we'd say, okay, so 1 EV equals 1 volt times the elementary charge, right? The charge on one single electron. So it turns out that we end up with, okay, now I can't see where the cursor is. So 1 volt times 1.6 times 10 to the negative 19 coulombs. Remember, this is joules per coulomb. So then an electron volt is just equal to 1.6 times 10 to the negative 19 joules. And that is what an electron volt is. Okay? It's a unit of energy. You often will see it when you're talking about things like particle accelerators. How much energy can we give each given electron? Okay? And this might seem like a small amount, but we'll do some calculations and see what we get from that. But I'm going to try to change this first.